I'm Grant Stewart from Los Alamos National Laboratory. Welcome to this introduction to an investigative report on electrical commissioning for high-performance computing centers. I represent a developing team from the Energy Efficiency HPC Working Group. Our team shared war stories about unplanned HPC misoperations. Many were power supply related. We agreed that better design and commissioning can prevent many of these conditions. We scoured the literature for insight. We agreed that power-related concerns can be initiated on the external utility or initiated within the HPC. Component ride-through characteristics are important. System starts, job failure, performance test runs, or running the highest demand programs are events that reveal latent flaws. One example event we discussed involved the tripping offline of X of Y cabinets in a large flagship HPC. High-speed meters on medium voltage supply did not see an initiating disturbance. The system was not damaged, but jobs were interrupted. We explored how this could have been diagnosed or prevented. We drilled down into the subcomponents of typical power supply units, fans, pumps, and variable frequency drives, and programmable logic controllers, to understand how they would react to power flow interruptions and susceptibility to malfunction or damage. HPCs exhibit rapid current flow changes, DIDT. The time period of interest is just a few milliseconds. In 2 studies by our team members, utility-side power showed corresponding voltage sags. We discussed the role of supply system reactance. The graphs in this slide were from those 2 studies. Coming back to power supplies, a team member showed benchtop data about the recovery of a power supply from a brief power interruption. He saw a surge in current demand and heavy DC load. We also explored the impact of harmonics from inductive loops and circuit topology. The utility grid is also subject to DIDT events, voltage changes, and harmonics initiated by rapid switching operations, lightning strikes, and faults. These can propagate into the HPC and cause performance disruptions or equipment damage. The investigative report will be presented as a conference paper by my colleague Joe Prisco from IBM. It is organized to channel the reader from general commissioning to the narrow focus unique to the aspects of HPC commissioning. We expect to write a longer paper and possibly an HPC commissioning guide. Lastly, I would like to share this list from our team membership. These experts have vast insight and depth in this topic. We could not list all team members here. Please look forward to a deeper treatment of this topic in the next year or so.